Good morning, everyone. Welcome back. Thank you for joining us. We're glad that you're here. I'm Steve.
And I'm Scott.
And together we are Backyard Musings, the Science and Technology channel.
Yeah, and we're talking about another health issue this morning. This is a good story, I believe. And we've talked about Alzheimer's and dementia many times, and it's a topic that is, again, pretty close to both of our hearts as far as trying to get a cure for this. We both know people that have been affected by it, and so let's get into it.
It's a good one. Researchers have identified a protein that links brain immune activity, metabolism, and amyloid clearance, suggesting a new way to enhance current Alzheimer's treatments. Alzheimer's disease can look like a set of grim headlines: soaring case counts, ballooning healthcare costs, and an aging population that makes the problem harder every year. But inside a home, the reality is quieter and more painful. Quote, "It's a slow bereavement," says Cold Spring Harbor laboratory professor Nicholas Tonks. You're not making that name up, Tonks, whose mother lived with Alzheimer's. Continue his quote, "You lose the person piece by piece." Would you like to know more?
That's a good way to put it. I've heard people refer to it as the long goodbye, because you never know. It's selective. People in the same family will not be remembered by a loved one, and another one will be, and that causes issues, I think. It's a tough disease. For decades, one of the biggest questions has been what starts the damage in the first place. Major suspect is brain plaque made of amyloid. Is that B?
Beta.
Beta, okay. A beta. Okay, so is that the amyloid?
Yeah, it's an acronym for amyloid beta.
Okay, so amyloid beta is produced naturally, but under certain conditions it can build up and form clumps. Those clusters are strongly linked to Alzheimer's progression, even as scientists continue to debate how many different biological processes must go wrong before symptoms appear.
And we've talked about amyloid beta before when we've talked about Alzheimer's. Tonks' team is now highlighting a different lever in that process, the enzyme PTP1B. In a mouse model of Alzheimer's disease, Tonks graduate student Yuxin Sen, I'm not making that up, and postdoctoral fellow Stephen Ribeiro Alves found that inhibiting PTP1B improved learning and memory, suggesting that dialing down this enzyme changes how the brain copes with the disease.
Tonks first discovered PTP1B in 1988 and has investigated its health effects ever since. That's a long study.
It's a long study.
Yeah. In the new study, his group shows that PTP1B directly interacts with spleen tyrosine kinase. Is that kinase?
I think you got it, yeah.
Yep. SYK is the short on that. A key regulator of microglia. Okay, the brain's immune cells. Microglia act as the brain's frontline maintenance crew, sensing trouble and helping clear unwanted material, including AB or A beta. Amyloid beta, is that what we talked about?
Amyloid beta.
Yeah, excess.
Quote, "Over the course of the disease, these cells become exhausted and less effective," says Sen. Continuing his quote, "Our results suggest that PTP1B inhibition can improve microglial function, clearing up amyloid beta plaques."
Okay. Alzheimer's risk is also influenced by factors beyond amyloid buildup. Conditions such as obesity and type 2 diabetes are strongly linked to a higher likelihood of developing the disease and may help explain its growing prevalence worldwide. Because PTP1B is already an established drug target for both metabolic disorders, these connections further support investigating its potential role in Alzheimer's treatment.
Newly approved therapies for Alzheimer's disease primarily focus on targeting amyloid beta clearance, yet offer only modest clinical benefits for many patients. Quote, "Using PTP1B inhibitors that target multiple aspects of pathology including amyloid beta clearance, might provide an additional impact, says Roberto Alves.
The Tonks lab is currently working with DEP-Y Med. I don't know what that stands for. Incorporate, some kind of company, to develop PTP1B inhibitors for multiple applications. For Alzheimer's disease, Tonks envisions a combination of therapies that pair existing approved drugs along with PTP1B inhibitors. Quote, the goal is to slow Alzheimer's progression and improve quality of life of the patients, he says. With this research establishing PTP1B as a potential therapeutic target for the disease, it may hold the key to doing just that. Okay, so again, this is one of those deals where if you had a loved one, a mother, a father, sister, brother, and they were suffering from this, I want to be at the front of the line.
Yeah, but the thing is, getting people to know this, getting the doctors familiar with this information.
Right.
That's key.
Right.
That's
right.
where we need you to tell your doctor.
Yeah, exactly. So if you found out, you've heard about this, and now you can go out and do a little bit more research on your own, then bring it to your doctor and say, hey, how do we get involved in this program? And because it's just, I mean, it's just terrible. It's a terrible disease for both sides. I mean, there's some, because I don't know if the people that are being affected by it really feel any pain from it, other than they get frustrated because they can't remember. But eventually it becomes an outsider looking in type of thing, right? Because that's the frustrating part.
Yeah.
You want the people to remember you. You want them to remember, like right now I'm dealing with this lady that she wants to drive her car so bad. And I keep telling her, you've got to pass driver's tests, written and physical. And I said, do you think you're able to do that? Well, I don't know. I said, well, okay, then study. I mean, I just don't think there's any way that she's going to be able to do that. And that's the frustrating part, right? Because if you look at her, she's this woman that looks healthy, but when you start having conversation with her, you just know it's just so sad. So anyway, tough deal.
All right, folks, thanks for joining us.
We'll see you this afternoon. Take care.